Welcome to cybersecurity class, where we are going to be learning a whole lot of stuffs. Okay, so we are going to be starting with computer A, and yesterday when we started our class, we were looking at different platforms. Started about what your cybersecurity is, and we also tried to look at what it entails. Okay, so let me give you like 1 or 2 minutes to ask what you learned from yesterday class, because I know we didn't go to bed until 2 a.m.
Thank you very much.
You're welcome.
Yesterday's section was introduction to
Your mic, I need to try and adjust the volume. You can check the audio volume of your computer.
not loud enough.
Yeah, it's okay now.
So I was saying yesterday's class, I learned about we did introduction to IT about and what it entails, and we also start of work environment related to IT. We basically at server point here to what where we are going to be getting for tasks, and most what we are going to do, the depth of what we are going to learn is going to be what we did yesterday. It has to do with server. So basically, we what server is, types of server, their usage, their functionality, and purpose environment. But data bank, data center, several captured different purpose. My data particulars and that is the physical server that you can create with another virtual set of server that does exist, like touch a little bit of virtual machine out. We learned from like was all that I might learning.
Okay. All right. So thank you so much for that. Today we'll continue to also try to understand your different components of a server. I hope you can still see my screen.
Yeah.
Okay, so now, as you can see, we are trying to look at components of a data center. Now, you already know what your data center is because we looked at it yesterday, and then you've been able to visualize how it works. So now, I want you to also highlight those things that they in black. They are telling you that the essential component of any data center often include cyber security systems, which is one of the things that you are going to be learning. It also include firewalls, your routers, your server, your storage systems, and your switches. So when they say switches, what type of switch do you think they are talking about? Let me ask you. What kind of switch come to your mind?
It's not the electrical switch. That much I can tell you. Switches are like interface between one component of a computer and the other component. Helps network both sets of those systems. Help them to feed information from one source to the other. Those are the switches I think you are talking about.
All right. It's not the electrical one. So we are now looking at network switch. Let's start from network switch. The reason why I like images is that it helps us to, to visualize and mentally have an idea of what we are talking about. Now, your switches are named based on the number of ports that they have. Okay, do you get the idea now? They are named based on the number of ports that they have. So this one, 1, 2, 3, 4, 5, 6. 6 plus 6, 12. This is 12. This is another 12, 24. This is 48. So this switch is called 48 switch ports. Do you understand now? Why? Because there are 48 ports here. There are 8 switch ports like this one. Of course, your switch too can be arranged in a rack. Still remember your rack?
Yes.
So basically, this is how they look like on a rack. This is how they look like on a rack. So which means, like you said, they are the end-to-end. They serve as the end-to-end connection for between the network and an end device. What do I mean by end device? For example, your laptop, your tabletop, your PC, your printer, they are your end device. But they also have this way and manner at which they also do their own work. So let me blow this image. Let me see if this image can be blown. How a network switch work. Basically, You always have a router. So your router serves as a gateway between the network, internal network, and the external network. Did you understand that, sir? Hello?
Yes, I can hear you.
I said your router serves as a gateway between an internal network. The one you are looking at is an internal network. And an external network. Example of an external network is your internet. The World Wide Web.
Yes.
You get. So if you have a company network, and I have a company network, all your computers can communicate to each other within your organization, right?
Yes.
Good. All my computers, all devices, I don't want to say computers now, because if you look at devices now, they are more than a computer that have been connected to a network now, right?
Yes.
Your phone, your network printer, your server, your laptop, your desktop, your game console. What else do you think can be connected to a Wi-Fi network?
Other communication items can be connected to.
Devices.
Huh?
Other communication devices.
Yes.
So when this laptop want to communicate to this server, it doesn't go like this. Do you get me? It doesn't go like this. First of all, communicate to the network. Let us switch. And then the switch interpret and send it back to the server. And then the server, for example, if the laptop is asking the server a particular question, it goes like this. Then this one relays what this one is asking for. And then the server, of course, we want to answer. The answer is sending. Is here. It will first of all send it here, and then this one will now send it to this one. So that process is as simple as it is. It's a very complex process. So, in fact, they are a very complex process. But that's how network basically, that's how they work. But now, why do you now have plenty holes, plenty ports in your switches?
You can connect as much devices or computer.
As much what?
You can connect as much devices or computer to the switch. Because basically what the switch does is collate information from one source to feed as many other end channels that have been connected to it.
Okay, so when networking was growing and becoming better, they started using what we call hub.
Yes, I know hub.
You know hub. Okay, good. Hub is like your switch too, right?
Yes.
They have same looks, the same ports and all of that. So, but do you know one thing about hub? For example, if what you have is if you have an hub here, this place now, can you see this diagram?
Yes.
You know, you have about 8 computers there now.
Yes.
And you have an hub here. So it means that if these want to talk to this, you know, this information must go like this, right? and then it comes there. If this wants to talk to this, the information goes there, and then it comes there, right? Which you all agree. But you see, for Orb is a very simple, it has a very simple design. It's not very intelligent. You get Orb is not very intelligent. What Orb does is to just repeat the data coming. So this one want to communicate with this one. So Orb will collect the information here and send it here. You get. Now this one too also wants to communicate to this one. At the same time, Orb will collect all the information at the same time. At the end of the day, before you know it, the network will jam because every one of them are trying to talk to every one of them. So what do you have? A chaos, a marketplace. Do you get the idea now? So Orb was not doing any effective work. The work was not that efficient. Why? Because you want to send an email from here to this place. This one want to send something from here to this place. Instead of them to wait for themselves, they will not wait. So at the end of the day, the data this one is sending can get lost in transit and not delivered to this one. Why? Because the whole street is jam-packed. Every one of them want to talk to every one of them, each other. Are you getting the scope like that?
Yeah.
So there came the advancement of switch. So your switch began to use some advanced technology. Okay. So one of the advanced technology that switch use, or the idea of that networking, was what we call CSDA, collision domain. Let me check for that advanced technology. So it was using this technology. Yes. I hope you're writing notes, sir. Just a little notes here and there.
Yeah.
So now the advanced technology of this technology is called CSMA/CD. CSMA/CD. So let me see what it meant by CSMA/CD. So your collision domain is defined as a single CSMA/CD network in which there will be a collision if two stations attached to the system transmit at the same time. So each port on a bridge or on a switch defines a collision domain. So I will explain that to you, sir. I will explain that to you. So there's a whole lot of switch technology. So your switch can do what we call content addressable memory. It has CAM. It can do what we call routing function. It can do what we call VLAN, virtual LANs, local area networks. And then different kind of switch modes. So now, all of these begin to help networking environment so that traffic can be communicated better, you know. Okay, so now let me look for, I want to just explain that CI/CD to you very well. So like I said, this was the technology collision detection. This is it. CSMA/CD. Carrier sense multiple access with collision detection. So they are now saying that, look at it. He said CSMA/CD is a medium access control MAC method used mostly in the early internet network for local area network. You already know your local area network. This is your local area network. This is your local area network. This is a local area network. So it uses carrier sensing. Carrier sensing, that is maybe the port or the cord or the cable. That's what they mean by carrier. Do you get? Whatever that is transmitting that traffic is what they mean by carrier.
Yeah.
Carrier sensing to defer transmission until no other station is transmitting. Now let me go back so that you can understand that scope. Now this want to talk. This one want to talk. But during, if they are using that hub that I told you about, all of them will be talking, and these idiots will be transmitting them, and then the whole place will be jammed because all of them are talking at the same time. But with the advent of this technology, that particular carrier is able to sense. So like it says, it's a medium access control, and it uses carrier sensing. So it can sense that, oh, okay, there is a traffic coming my way. Now ask itself, oh, do I have a pending job here? No. Okay, let me allow you to pass. Just like the way your normal traffic control, your traffic light works. What does it do? It regulates, your what now? It's your traffic. It try to light one part and say, okay, when you guys finish going, okay, you two should go, and all of that. So this is something like that. So it uses carrier senses to defer transmissions until no other stations are transmitting. What do they mean by no other station? Each ones are call station, each computer like this. So if this one want to send an email to this one, it will begin to ask the question, Alpha, are you available to talk? It's like calling you and say, hello, Mr. Musa, are you available to talk? You can say, no, I'm busy, right? So I will go and sit down. But if I say, hello, Mr. Musa, are you available to talk? Say, yeah, I'm talking now. Yes, you can talk now. What do? I begin to talk to you or talk with you. So that is one idea about carrier sense. Now, they are saying that it uses carrier sense to defer transmission until no other stations are transmitting. So now, this one is sending an email to this one. The email is large, or is sending a video to this one. The video is large. Okay, he's sending it little by little. So this one will want to send an email to this one. But what your switch, assuming you have your switch in the middle here, what will your switch do is to sense that, okay, wait, this one is working. Allow this guy to finish sending his file. Then I'll now allow you to send your own. Do you understand? No azu, no crying. you know, and that is what that means, how it means. Do you get? So let's look further in. So this is used in combination with collision detection. So the CSMA, which is your carrier sends multiple access with multiple access, they now combine it with another technology called collision detection. Of course, when they are using the hub, because a lot of people are speaking, a lot of stations and computers are talking at the same time, there's going to be a lot of collision of traffics, right? And because there's a whole lot of, so now this technology now has also been designed to detect collision. So if once you know that this traffic and the other one might likely jam each other, it will stop them. You know, that's the one of the technology too. So this is used in combination with the collision detection, in which a transmitting station detects collision by sending transmission from other station while it is transmitting a frame. When this collision condition is detected, the station stops transmitting that frame. It transmits a jam signal and then wait for a random time interval before trying to resend the frame again. Do you understand? So at that level, they are sending a frame, not packets, because that is at level 2. You understand? So all of this, you will get to know. I'm just trying to open a little introduction to us. So that is number one thing from your data center. Now let's also look at your router. So there's nothing new. You are sure of your router, you already know what your router does. But if you look at this image, you might have a little idea what a router does.
Yes.
So now, your router, of course, transmits. It transmits. How do I put it down?
This is the router is wave band, isn't it?
Router is what?
It's wave. It's wave. It's what do they call it? The broadcasting channel is through wave. Just like an antenna. You're seeing an antenna, it has antenna.
No. The antennas are meant for Wi-Fi.
Okay.
You know, Wi-Fi is a radio broadcast.
That's what I'm saying.
Basically, and then is the receivers too, so that it can also receive from your modem or ISP. Do you understand? It can receive signal because now, like I said, your router is the gateway. Between your home or your organizational network, your private network, and the internet. So can you see now? Can you see internet? So there's no way all of these things you are looking at, they are inside a private network. And what do I mean by private network? Network that is belong to individuals and you know, organizations. So within organizations, all computers can communicate together. They can be networked together and all of that. But if any of the computer wants to connect to the internet, it has to go through what we call a router. Because the router is the gateway. You understand? Okay. So let's just take it little by little. Let's check another issue. Of course, storage system. We are looking at your component of a data center. You still remember your data center?
Yes.
Where all these components. So As in, if you look at this side now, of course, you know what this side is talking about. You know what they are, don't you?
Yes.
What are they?
They are servers. They are servers arranged in a rack.
They are already in a rack and then they are networked together.
They are
You can
network.
see table. So, but you can't see anything like that in front here now. You can't see anything like that. This one look like bookshelf, but they are still server. So what you are looking at, if this is the front side, this is usually the back side. Can you see it?
Mm.
Can you see the computer that this madam is working on? You use it to connect to the server. So basically, this is how your storage server looks like.
Okay.
So there you can do your hosting and then your cloud. You understand? It's just like the beginning of your cloud too. The cloud too has some massive technology called hyperversion. I call what's it called? Virtualization. So virtualization is the core background for your cloud. Though your cloud still store data in your storage account.
Mm.
You understand? But so okay, let's move on to the next one. Well, there won't be so much difference between your servers and your storage systems. Okay. So your storage system too are your servers. Okay. It can just be your storage server, like I explained to you yesterday.
Yeah.
Or let me see. Let's see if you can see a storage server. You can see that if I say storage system, it might take me to different things. So look at the way they look like. They look like a one tick box. And look at the prices, sir. Are you seeing the prices?
Yes.
Just a minute, sir. Hello, sir. Can you hear me?
Yes.
Can you hear me, sir?
Yes, I can hear you.
I hope you are learning something new.
Yes.
Okay. So just for us to know the component. So you can see that your server, see this one look like. What does this one look like?
Looks like decoder.
You said decoder. But what I taught you yesterday, sir.
Mm.
From what I taught you yesterday. Look at
Yes,
it
sir.
very well.
Okay.
What does it look like? What does it look like?
Blade server.
Exactly. Look like your Blade server. But meanwhile, it's a storage server.
Okay.
Okay. So which means that your storage server too can be arranged as a Blade server. Okay. Just for you to understand what your storage server and your storage. So they are meant for backups and all of those stuff. You get. So this is how they look like inside your Blade server. See, can you see? Can you see what is inside?
Mm. It looks
Your
like
normal
hard.
disk. It look like what?
Hard disks.
No be say it look like hard disk. Then be hard disk. Then be hard. That's why I open it for you. See, you can see it now. It's those hard disks that they merge together. They now have a way of arranging them.
Okay.
Do you understand?
Okay.
So they store, just like if you put your video inside your computer, you can also put video here too and go your way. You get the idea?
Yes.
So what's most important is, you learning something new and then taking advantage of it.
Okay.
Okay, enough of that. Yes.
What about the firewall?
I was going to firewall. Okay, so your firewall to look like your firewall can be software and can be hardware, just like your server.
When you say hardware, how?
Hardware. Okay. Come. Can you see the way they look like? This one even look like your router. Can you see it now? Alisa?
Yeah, I can hear you.
So if you look at it, they are all basically similar. This storage server look like blade look like switch. Your switch look like what's it called again?
Firewall.
You understand? So they all look alike. But have it at the back of your mind that when it comes to firewall, there are physical components an organization can buy and they will tell you this is our firewall. Then there are also software components of it. And then these are some, Okay. So what does it do? You try it so let's look at this information. What does it do? Firewall. So you have a private network. Can you see? Your organization, your company, and then of course you know that okay, so within your private network now, you have connected it together. Then at the edge of your network, you now put what you call a firewall there. So within that firewall, there's what we call firewall rule. So that rule will be the one to if any of these want to connect to the internet now, they'll go through the firewall. So can you see the image, sir?
Yes.
Okay, so this is all your computers in your organizations, which they are very secured. But at the same time, you try to put an extra layer of security on it called firewall. So of course, this is how your firewall looks like, as in just representation. Now, see attackers. This is what you'll be doing soon. You'll soon be attacking some websites now. Yes. So see attackers. So what is blocking them?
Firewall.
Firewall. Even the attacker can come all over the internet and they will block you. So, or let's check this. You see the same? Still the same. So there's a local area network, which is within the premises. Then there's a firewall. Then we have wide access. So can you see it now? That so this is a server. This one at the meeting. So it's saying that before all this internet thing can enter into your local area network, it has to go through firewall. You understand?
Yes.
So basically the diagram is just for you to see that, okay, what a firewall does is to just break and stop some brute attack. Do you understand? So look at this now. There's a private network here inside there, but there's a firewall. So firewall will have set up some policies and secure the environment. And then there's an internet. So that's to that. Let's check the last one. Okay, cybersecurity systems. Of course, one of the things that your data center needs is your cybersecurity system. Okay, just a minute. All right. Okay, so maybe in the next 10 minutes, I'm going to just round up the class so that by tomorrow we'll start proper with an hands-on approach. What about that one, sir?
Okay.
So I just do that introduction to you for you to just have an idea and then see how it's, how it's going. Okay. All right. Okay, so that being said, these are some of the components you see in your data center. Either it is cloud, public, or private. You always see them. So, okay, so Mr. Musa, please, let's reconvene tomorrow. This is 1:45. Let's reconvene tomorrow. And then we are going to be starting proper. So this is where we are going to be starting tomorrow. I guess I've helped you out a lot in giving the introduction. So we'll start proper. We'll start proper tomorrow. So thank you so much for your time tonight. Can you hear me, sir?